Alright, example 8. Third order differential equation, linear. Go ahead and put it into the auxiliary equation. So we do so. And now we're going to find all of our P's and Q's, possible values that go into -4, 1, 2, and 4, plus or minus all those. Leading coefficient is 1, so again, Q is just going to be plus or minus 1. Now let's use synthetic division. We'll pick one of these values and let's choose +2. So we choose +2, see if it works. Alright, now, again, I'm going to put in my auxiliary equation down here. Notice there's no m, so the placeholder for m is just a 0. So you make sure that you include that. Don't forget that. Alright, so take 1, bring it down. 2 times 1 is 2. Add -1 plus 2. It's going to be 1. 2 times 1 is going to be 2. 0 plus 2 is going to be 2. 2 times 2 is 4. Add -4 to get 0. We found a root. So 2 is a root. So m equals 2 is a root. What's left is going to be your following equation. It's kind of like your remainder. So it's going to be m squared plus m plus 2. So there is that. Alright. Now, I'm looking at this. I can't find two numbers that go into 2 that add to give me 1. So I'm going to go ahead and use the quadratic formula. So I set up the quadratic formula using my a, my b, and my c. And when I do the quadratic formula, you're going to get -1/2 plus or minus I squared root of 7 over 2. Alright, complex. So what's our alpha? Alpha is -1/2. What's our beta? Radical 7 over 2. So now let's go ahead and plug in to our formula. M is taking care of c sub 1 e to the 2x, and then our complex roots are going to be taken care of c sub 2 e to the -x, cosine 7 over 2x, and then e to -1/2 x, sine of radical 7 over 2x. Hopefully you didn't find that to be too bad. Again, this is a lot of algebra too. Really not much calculus, so this is all algebra too. So you shouldn't have a problem with this. Alright. So example 9, y triple prime minus 6y double prime plus 12y prime minus 8y equals 0. So here we have a third order linear differential equation, and we're going to solve for m. So again, I put in the auxiliary equation, and again, I'm trying to find numbers that go into -8 to find my possible zeros. So 1, 2, 4, and 8 all go into 8. Let's try 2, see if that works. Plug in 1, bringing that down. Again, this equation right here, these numbers come from our auxiliary equation, all the coefficients, except for that 0 part. Alright, so bring the 1 down. 2 times 1 is 2. -6 plus 2 is -4. 2 times -4 is -8. 12 plus -8 is 4. 4 times 2 is 8. Add those 8 and -8 together, you get 0. We have found a solution. So because 2 is a solution, I say m is equal to 2. And then we're left with this as our remainder. So we get m squared minus 4m plus 4 equals 0. And we're going to go ahead and factor that one because I can. I notice, oh, hey, that's just m minus 2 squared. And so if it's m minus 2 squared, then m equals 2 and 2. So here, not only do I have a repeated root, but I have a repeated root, 3 times. I have 2, 2, and 2 for my solutions for m. And so therefore, when I write out my solution, it's going to be y equals c sub 1 e to the 2x plus c sub 2x e to the 2x plus c sub 3x squared e to the 2x. So again, if it's repeated, if you have your repeated root 3 times, your highest x is going to be x squared.